Hi, hello students. So I think more people has to join. Okay, so if they are not able to join, they can go for YouTube live. Okay, so I'm making this YouTube live also. So later you can watch this video what we are having the class now. Okay, so I'll share the link of the YouTube also in 2 minutes. So welcome all. I'll be taking you the class. Okay. So welcome all. I'll be taking you the class. Yeah, so here we go. So welcome. Welcome to the class of what we are talking about. We are talking about the de-multiplexer and demultiplexer, and we'll be going for the concept of encoder, and we go for comparator also, magnitude comparator. So I think everyone is able to hear my voice, students.
Yes, sir.
Thank you. Can you able to see the screen?
Yes, sir.
Okay, thank you. Okay, so here we see this right. So we go from demultiplexer and encoder and comparator, magnitude comparator. So today class we start with the demultiplexer. So how it will be, right? So this is one of the important topic of the combination circuits in the digital design. Okay, so here we see, so we go for the decoder, demultiplexer. So demux we can call demux or demultiplexer. Okay, demux or demux or demultiplexer. Okay, shortly we can call it as demultiplexer. Right, so this is what, so here, so we take generally the box. So what we have the box. Okay, so this box, inside we have the circuit. Okay, so now we are taking the circuit for demux. Okay, so for demux we need to know what is a multiplexer. Okay, so we have the multiplexer. So multiplexer, we are having many inputs. Okay, it is 2 power n inputs and 1 output. Right, so here we have n inputs. Okay, and n selection lines. So, sorry, 2 power n inputs and n selection lines. We can call it as selection lines. Right, so here we can see one output. Okay, n selection lines and 2 power n inputs. In the same way, here demultiplexer means the reverse. Okay, the reverse of the multiplexer. So reverse of the multiplexer, reversing the box. So we have the same n number of selection lines. Okay, and what we have here is one input. Okay, and 2 power n outputs. 2 power n outputs. Okay, so this is what we have seen here. This is a multiplexer, figure for multiplexer. Okay, in multiplexer we give the input. Okay, we give the input and we select the input. Okay, in the multiplexer we select the input. In multiplexer we select the input. Okay, depending upon the selection line, that will be coming to the output. So depending upon selection line, that will be coming to the output, that will be connected to the output. Okay, so here you can see a small switch will be present here, like a small switch. Okay, so this will be connected here, so it will be, okay, so it will be connected, so like switch. So depending upon our selection line, if it is 4x1 multiplexer, let us take a small example of 4x1 multiplexer. So 1, 2, 3, 4, 4x1 multiplexer. Okay, by the symbol 4x1 we can identify it is a multiplexer because 4 inputs. So we can have I0, I1, I2 and I3, and here we have one output, and 4 inputs means 2 selection lines. Right, so here we have 2 selection lines and 4 inputs. So here I am writing a line with one small cross here. Cross is nothing but it is showing the number of lines, 2 lines, instead of showing 4 individual lines here like this. So we can show a single line with some small cross and that indicates the number of lines. So here we have 2 lines. So what are the 2 lines here? We can go for selection lines S1 and S0. Okay, So depending upon the selection, so if it selection is 0 0, okay, so output here we are having the output. So depending upon the selection lines 0 0, so 0 0 means I naught will be the output, so I naught, and 0 1 means I 1 will be the output, 1 0 means I 2 will be the output, and 1 1 I 3 will be the output. So here we are selecting the inputs to go to the output, right? So we are selecting the inputs to go to the output, right? In the same way, here we go for the demultiplexer. So demultiplexer in the reverse manner. So this is a box, and here we have the demultiplexer 1 by 4. Let us take 1 by 4 or 1 by 2. Okay. So selection lines are common, same. So two selection lines we can have, S1 and S0, and we are having one input and 4 outputs. Okay. So this is the input, okay, and this will be the output. Let us take outputs as Y0 and Y1 and Y2 and Y3. Okay. So depending upon the selection lines, so this input will be connected to the output. Depending upon this selection line S1 and S0, so this input will be connected to the output, and remaining outputs will be not means they will be in different states, different outputs, but we consider only one output, that is Y0. Okay. Y1 will be something, Y2 will be something, Y3 will be something, but depending upon our selection line, if it is 0 0, so this input will be connected to the, so this input will be connected to the output, that is Y0. Okay. So here we see the same truth table here. So we take the truth table. Okay. So in the truth table, so S1, S0 are the selection lines. Okay. So S1, people are entering. Tell your friends to go to online also, so if they want, so if they are not able to join. Okay, right. So I have given some stream also. So here we can see S1 and S0 and are the inputs, I mean the selection lines, and we have Y0, Y1, Y2, so Y3. Writing the outputs is not means no need to follow the order. Okay, Y0, Y1, Y2, Y3. So we can write Y3 here, Y2, Y1 and Y0. So you can write in any manner. Okay, so we are just showing the truth table. So it is not any we don't have any rules. It should be written like that only. So it is for our understanding sake. So truth table gives the values, outputs for all the input values. Okay. So now we go for the input values 0 0, it is selection line 0 1, 1 0 and 1 1. So when you are given 0 0, what happens? This input, let us take input is I is the input. So I will be going to the Y0. Okay. So I here. Okay. And remaining will be don't care conditions. Don't care means whatever it may be, we don't consider. Whatever it may be, we don't consider. And here for 0 1, so we don't have any. So this will be this means, so 0 1 means y1 will be I. Okay, remaining all will be don't care conditions. Okay, and here if you want specifically you don't want don't care conditions, you want something else, means we can go here by making them zeros also. We can go for zeros. We can make them zeros. Okay. We can make them zeros. So we can go for zeros, and here 1 0 means y2 will be the input, it will be connected, so remaining will be zeros. 1 1 1 1 means y3 will be I. So whatever the input may be 0 or 1. Okay, let us by whatever the input is equal to 0 or 1, so we connect to the y3. So 1 1 means s1 and s0, or 1 1 means y3 will be connected, that input will be connected to y3. Okay, so here this is what a small demultiplexer. Okay, what we take here, the small demultiplexer. Right. So now we need to go and draw the circuit diagram. So how to draw the circuit diagram? Here we have, so y naught equal to, so y naught equal to what here? Y naught equal to I. Y naught is equal to I when S1 and S0 are 0 0, means S1 bar, S0 bar. Okay, so here we have y1 equal to I. Okay, I is common, I when S1 is 0, S0 is 1. Okay, and here also we have y2 equal to I when S1 is equal to 1 and S0 equal to 0. So whenever wherever we are having zeros, there we give bar, Okay, so that is how we can draw, and we can get the expression very easily. So first understanding the block diagram, so the functionality of the demultiplexer, and what we have the idea that demultiplexer we are keeping in the form of some truth table. Okay, and here we have the expressions. Okay, so y3 equal to what? I I3 equal to I when input equal to S1 equal to 1, S0 equal to 1. So this is how we write the expressions. Okay, so when we write this expression, we need to draw the circuit diagram. Okay, now we go and draw the circuit diagram, and here you can see I is common. So I is common, so we draw I here. Okay, we draw a line I, and we draw a line for S1 bar and S0. Okay, so I is running the wire like this. I is one input, S1 is one input. To that we are having NOT gate also, because in some cases we are using S1 bar also. Okay, and S0. Okay, and S0 bar. Okay, this is what we are drawing here is for our simplicity sake, and what we have, if you want to draw anything, how you want to draw, you can draw. Okay, so what we are drawing here is for our simplicity. Okay, and here you can see I, S1 bar, S0 bar, and here we can see for how many outputs we are having? 4 outputs. How many outputs we are having? 4 outputs, y0, y1, y2 and y3. Okay, so for each output we are having each expression. So how many? 4 expressions. So we represent that 4 expressions, that is 4 outputs in the form of logical diagram. So here we see y0 is the output. For y0 we are using one AND gate. One AND gate is enough, and here it is y0, one output. We got one output, and here second output, that is also we are using the AND gate, y1, and for third output we are using y2, and fourth output we are having y3. Right, so here we see, so what is the expression here? We are having y0 equal to I into S1 bar, S0 bar. So what we have here, so IE, so AND gate, it should be connected to AND gate y to y0, that is, and IE S1 bar. So we need to go for the dark dot, so that it is having some connection. So here we can see the crossings are not the connections. So here we have dark dot, so I into S1 bar s0 bar. So you can see on top, so I into s1 bar s0 bar, so y0, that is for y0. And for y1, I is common for everything. We want I only as the output. I will be the output when s1 bar, that means s1 equal to 0 and s0 equal to 1. S1 equal to 0 and s1 means 0 1, so 1 means here. So we connect like this, right? So here also for y2 will be I is common, I into s1 s0 bar. Okay, and here also we just come down slowly, and here we can see I AND get and s1 and sorry here. We're getting dark dot line, so here we go like this. Okay, so this is what. So this is I, and this is s1, and this is s1 bar, and this is s0, and this is s0 bar. Okay, so this is what you can get. Okay, so this is what the circuit diagram, logic diagram. Okay, so figure, this is a figure for logic diagram of demultiplexer. Demults, that is 4/1 demux. Okay, so you can go for 2/1 mux also. So you can take the assignment. So you can take the assignment question here. One assignment. Okay. Question. Draw a logic diagram for 2/1 demultiplexer, demux. Okay, and we go for your practice, that is 8/1 demux. Okay, so this is what you can practice. So I have given yesterday 4/1 mux, sorry, demux means sorry here, sorry, demux 1/2 demux 1/2 demux and 1/8 demux. Okay. Okay, students, so here, are you having any doubts here, students? Are you listening?
No, sir.
Everything is clear?
Yes, sir.
Okay, so you just see, I just minimize this screen. Okay, so you just go through once how we are going here. So demultiplexer. So demultiplexer, here you can see the circuit. This is a block diagram. So block diagram, one input, many outputs. We are having n number of selection lines. Okay, so n number of selection lines means 2 power n outputs. Okay, that is reverse of the multiplexer. Okay, and here you can see demultiplexer, the functionality of the demultiplexer. So 1/4 demultiplexer, and how it is functioning. So the input is sent to the output depending upon the selection lines S1 and S0. Okay, so to which output you want to connect. Okay, to which output you want to connect, so that is depending upon the selection line. So selection line, if it is 0 0, so it will be connected to y0. If it is 0 1, it will be connected to y1. If it is 1 0, it is connected to y2, and if it is 1 1, it will be connected to y3. Okay, so we have the expressions also. We got the expressions I. So we select I. So y0 equal to I into S1 bar S0 bar, y1 I into S1 bar S0. So depending upon selection lines, we are getting the expressions here. Okay, So you can, I think you can go for the logic diagram of 1 by 2 demux and 1 by 8 demultiplexer. 1 by 2 means one selection line. 1 by 2 means one selection line. Okay, so 1 by 8 means 3 selection lines. Okay, so we are not talking about the selection lines here, because means 1 by 8 means internally we need to see that 3 selection lines are taken for the circuit. Okay, one selection line and 3 selection lines. Okay, so this is what the topic of the demultiplexer. So can we go for the next topic? That is what we are talking about is the encoder. Can we go for the encoder, students?
Yes, sir.
Okay, thank you. So I'll save this. So I'll save this as what it is, demux. Okay, now I go for the new, that is we are going for now encoder. Okay, we go for encoder. Okay, so before going to this encoder, we see once again decoder. So a decoder, what it is the decoder? So decoder, we take the box. Okay, so depending upon our inputs, if it is 3 inputs, okay, so n inputs means 2 power n outputs. Okay, 2 power n outputs. So 3 inputs means 4, 5, 6, 7, 8 outputs. Okay, so 3 inputs means 8 outputs. And here you can see one enable. Okay, one enable you can see here. Okay, so this is a 3 by 8 decoder. Okay, to the 3 by 8 decoder, enable will be present. If means it is like a switch to the means it will be a main power supply, supply to the our house. Let us take our house. So it will be like main supply. So means in to a house we can have the main power supply. So if the main power supply is on, then only we can see the current will be passed to our house. Okay, so it will be means then only we can see some functionality can be taken place. So where we can switch on the fan, TV, and etc. Right. So here it is like when enable, if E equal to 1, if E equal to 1, if enable E equal to 1, then only decoder works. Then only the decoder works. Okay. So here if enable E equal to 1, then only means outputs of then decoder outputs of decoder. Okay. So here what is the functionality here? We can see the truth table now here once again, the decoder truth table. Okay, so enable. Okay, and so let us take the selection lines means that are the inputs. So inputs can be taken as inputs I2, I1 and I0. Okay, and we have the outputs 8 outputs. So Y7, Y6, Y5, okay, Y4, Y3, Y2, Y1 and Y0. Okay, if enable equal to 0, okay, whatever the input you give, okay, so if the power supply mains are off, whatever the switches you put, okay, so you put off or on, whatever, okay, so the output will not be working, all will become 0. Yes or no? All outputs will be 0 if we are not having the main power supply. So whatever the input you give, you switch on also, you can see that functionality will not take this. Okay, the same way here, if enable equal to 0, so no, whatever the switches you give selections, that outputs will not be shown. Okay, if enable equal to 1, then only we can get the output, that is if it is 0 0 1, so one output will be 1 and remaining all will be zeros. Okay, so if enable equal to 1, then only you can 0 1 0, so y1 will be 1 and remaining will be zeros. If enable equal to 1, then 0 1 1 means y3 will be 1, sorry here, so 0 0 condition we have not taken here, 0 0 condition. So here we go for 0 0 condition. When enable equal to 1, 0 0 0, y0 will be 1 and remaining will be zeros. 0 0 1 means y1 will be 1. Sorry, so here it is 0 and here it is 1 and here it is 0 and here it will be 1. Okay, so understanding, students. So when 0 1 1 means y3 will be 1 and 1 1 0 0 means y4 will be 1 and 1, that enable is 1, that 1 0 1 means y5 will be 1. The same way 1 1 0 means y6 will be 1 and 1 1 1 means y7 will be 1. So remaining all will be zeros here. Okay, I am not okay, so I am not writing here, so you can understand, I think. It's 0 to the 0. Okay, so this is what the functionality of the decoder. This is the functionality of the decoder. Okay, understanding, students. So when enable equal to 1, then only we will be getting the output. If enable equal to 0, it will not work here, right? So this is what the functionality of the decoder. So now we see the encoder, how it works. The encoder works here. Okay, so how the encoder works here. So encoder will be working means we go for 4 by means encoder, say the reverse of the decoder. So we go for the reverse of the decoder. We take the simple example. Okay, so there is a box here, so we just go with the enable. Okay, with the, we can have with the enable and 3 outputs. You can go for 3 outputs and n inputs. So reverse 1 2 3 4 5 6 7 and 8 inputs. Okay, so what it will be, 8 by 3 encoder. So that means 8 inputs and 3 outputs. Okay, so the functionality will be the same the reverse manner. So what will be the functionality here? Okay, what will be the functionality when here we can give the inputs as I0, so I write here and it is will be I7 and here the outputs we can go for y2 y1 y0, we can give any name here. So let us take the I0 I1 truth table, we are going for truth I0, I1, I2, I3, I4, I5, I6 and I7. Okay, and here we have the outputs. Okay, we go just, so we have a lot of space here, we just go down. Okay, so we can see here, so I0, I1, I2, I3, I4, I5, I6, I7, and we are having outputs Y2, Y1 and Y0, and if you want we can have the enable also. Okay, so enable means it gives okay, so we have enable gives whether the output is correct or not. Okay, enable gives whether the output is correct or not. We can have the E, or we can sometimes we can have V also, verify. Okay, V is nothing but the verification means whether they are correct or not. Okay. And now here we can see I not equal to, now what will be the input of the decoder, what is the output of the decoder. Here we can see output of the output of the decoder. Okay, so here we have the output of the decoder is 1, only one output will be 1 and remaining will be zeros. And here if it is 0 0 0, that means y0 will become 1 and remaining all will be zeros. And here an E equal to 1, that means it is a valid input, and here we can see it is a valid because when E equal to 1. Okay, and here we can see in the reverse manner what we can get here. So here when I not equal to 1, one output will be 1 and remaining will be zeros, so that means 1 means 0 0 0, so E equal to 1, that means valid input, it is valid input. So enable can be taken here seriously, or we don't take if you want, you don't want to take, so you can ignore also. Okay, you can ignore. So for a while we just keep it aside. Okay, so now here I not equal to means now I1 will be 1, one input will be 1 and remaining all will be zeros, so that will be 0 0 1, and now one input will be 1, that is next we give to the I2 equal to 1 and remaining all will be zeros. Okay, so 0 1 0. Okay, sometimes if you are getting two ones here, so that means 0 1 1, if I am getting 0 1 1, that means it is invalid, so invalid means E becomes 0 here, at that time E becomes 0, and here it can be whatever the input it can be, we can have, but it will be not a valid. So whatever the output we are getting here, it will be not a valid output, means that output is not correct because input is not correct. So we are getting two ones, and here that can be identified when E equal to 0. If E equal to 1 means no problem, and if E equal to 0 means it is invalid. Okay, so we just take here, we just remove, so we write it last here. Okay, so this will be the, now we can take it as 1. So here we write I3 equal to 1 means 0 1 1. Okay, so 0 0 0 0 1 0 0 0, so I4 equal to 1, one output is 1 means 1 0 0, and the valid input, that is 0 0 0 0 0 1 0 0, so 1 0 1, so valid output. So 0 0 0 0 0 0 1 0, that will be valid out to 1 1 0. So because at I6 equal to 1, so 1 6 means what, we can go 1 1 0. Okay, now I7 equal to 1, that means all 3 ones, sorry, 1 and 1 here. Okay, so this is what you can see here, right? So if let us a small example, if I take if I am having means some 1 here, 2 ones if you are getting, so this kind of condition we are getting, so that is whatever the means we don't get means we can get the output, but it is not valid. So for identifying that, we can make E equal to 0 or V equal to 0. Okay, so for a while we take it separately, this E. Okay, so we just take only this part for our consideration. Okay, so we see only this one, right? So now we can see what is the output here, y2. So how many outputs? 3 outputs. So here we have 3 outputs. Okay, so 3 outputs means 3 outputs, y2, y1 and y0. So we need to get 3 expressions. So what is y2? Y2 equal to sigma of, so what are they? So y2 equal to what? So here we have I4. Okay, so no need to go for sigma also. So y2 will be what? Y2 is what? Y2 equal to y2 will be 1 when I4 equal to 1, or I5 equal to 1. So I4 I5 plus I6 equal to 1, or when y2 equal to 1 when I7 equal to 1. So when here we can see y2 will be 1 when I4 is 1, I5 is 1, or I6 is 1, or I7 is 1. Okay, and here in the same way we go for y1 equal to what? So wherever we are having 1, so wherever we are having 1, so when I2 equal to 1 plus I3 equal to 1, means I2 equal to 1. So y1 will be 1 when I2 equal to 1, or I3 may be 1. Okay, so it may, we can get I3 equal to 1. So whenever we are having I3 equal to 1, we get the output as 1. Okay, and here we can see here when I6 equal to 1. So here we see, just I take with some color. Okay, so we are selecting here. So we are selecting, we are writing only for this ones. How we are writing for the ones? Okay, so I2 equal to 1 when I2 is 1. So whenever we see I2 is 1, we directly get y1 equal to 1. Okay, when will be y1 equal to 1? When I3 equal to 1. Okay, and here we can see, and or when I6 equal to 1, or I7 equal to 1. This is what we can write for. And y0, we can write for y0 equal to 1 when I1 equal to 1, where it is I3 equal to 1, and here where it is I5 equal to 1 and I7 equal to 1. So we write here. So when I1 equal to 1, or I3 equal to 1, okay, I3 equal to 1, or I5 equal to 1, or I7 equal to 1. So this is what the outputs we are getting here, and here we can write simply the output. We can draw the circuit diagram. We can get the circuit diagram very easily here. So what will be the circuit diagram? Here we can draw from this. Okay, so can we draw easily? So how many outputs we are having? 5 3. So we go with another color here. drawing the circuit. So OR gate, here we are having the OR gate. Okay, we go for the OR gate. 1 OR gate, 2 OR gate, and 3 OR gate. Okay, so this is y2 and this is y1 and this is y0, and here we can see how many lines. y4, we are having y4. So let us take sorry, i4. We don't have i0 equal to 1. We don't have i0 equal to 1. Okay, for we don't have any output here, so no need to go for i0. Okay, so we draw the circuit here. I4, okay, so this will be I4, and I5, let's take I5 here only. Okay, I6 and I7. Okay, so what we draw a big one. Right, and here we see this is I4 and this is I5 and this is I6 and this is I7. In the same way we go for y1 equal to I2. So we have I2 will be running here like this, I2. Okay, I3. Okay, I6, we can take I6 from here, I6, and I7, we can draw I7 from here. Okay, and for y0 equal to I1, where is I1? So here, sorry, it is I2 and this is I3. I1, we are getting the I1 directly. I3, from here we can have the I3. And here we have I5, can get I5 from here, I5 and I7 from here. Okay, we can draw very simply we can draw like this. Okay, so this is what the circuit for the encoder logic diagram. Okay, so this is what we can see. This is very simple. So this is the reverse manner of the decoder. So what we have seen here now is the encoder. So decoder, how is the decoder here? This is what the decoder. Okay, so the reverse manner is the encoder. So here the first thing is what we need to know is we need to understand the functionality. We need to understand the functionality. After getting the functionality first, okay, and second getting the expression, and third is drawing the circuit diagram. Okay, first functionality, understanding the functionality. So everything for all the circuits, first functionality and the expression, and we need to get the expression. It is very easy to get the expression. Okay, so this is what the class for today. So already some time I have taken more. So actually I had thought of taking only the half an hour, but we extended to 1 hour. Okay, it's okay.